Maintenant, on va essayer une chose. On va voir si cette fois-ci on se plante, parce que la dernière fois, on l'a essayé aussi, puis on ne s'est pas planté. On va réessayer une vidéoconférence, puis on est très content parce qu'on a Noah Iliinsky, qui est un designer d'information puis visualisation. En fait, c'est en anglais, ça fait que je vais le faire en anglais aussi. He's also an author and speaker with a strong foundation in UX. He's interested in making knowledge accessible and building better knowledge sharing tools. He's the author of Designing Data Visualization, as the technical editor and contributor to Beautiful Visualization, both published by O'Reilly Media. He's working now as Senior UX Architect at Amazon Web Services. So let's try and see if Noah is there. Oh. Hi. How are you? Can you hear me? I think you need to enable your microphone. Hi. So, do you hear me now?
Yeah, sounds good.
And we hear you. Perfect. Excellent. So, we are, I don't know if you can, yeah, we'll put this on full screen, just here. I don't know if you can see this beautiful audience that is ready to hear you. So please welcome Noah, which is in Seattle, and we're ready to hear you.
Any intro, or should I just dive right in?
Sorry?
Do you need an introduction, or should I just dive right in?
Well, actually, I already introduced you, but feel free to introduce yourself as well. Yeah.
I'm Noah. I'm a UX architect, and I have a lot of opinions about data visualization. The one thing that I will sort of preface the whole conversation with is that I got into visualization accidentally when I was in graduate school, studying user experience design, and so I always brought a very sort of user experience design process with me as I do visualization design. And so the talk that we'll give is fits very nicely with your theme. It's very much about a user-centered perspective on how to do visualization design, which I think is the right way to do it. So here we go. Let's see if I can share that. Does that look good?
Perfect.
Okay. 4 pillars of visualization design. This also applies to all kinds of other, any sorts of other design, writing letters, all these sorts of things. So this is the process. We have to start with our purpose. Why are we doing this? By the way, number one, don't worry about writing this stuff down. I'll send the organizers the link, and you can take the PDF home with you. So yeah, you can just watch along. Don't feel free. I've given some talks, and somebody takes a photograph of their phone of every slide, and I'm like, I'll just give you the slide deck. It's fine. It's easy. All right. So this is the process, and we're going to talk about each of these 4 for a few minutes. So number 1, the purpose. Why are we doing this? That has to come first, because that informs everything else that we do. Number 2, the content. What of all the data that we're working with, or all the data that we have available to us, how much of it does our customer actually need? What do we need to show them? Number 3, the structure. This is finally now we get to talk about what graph type, after we've figured out our purpose and after we've figured out our content. And finally, formatting, and this is typography, color, all that stuff. That comes very last in the process. Good so far? Yeah. If somebody has questions, like wave your arm and maybe I'll see it. Somebody say, wait, we have a question. Otherwise, we can do it at the end. Okay. So the purpose. You have to start with your customer. This is Jeff Bezos. He pays my paycheck, so ultimately he's my most important customer. But you have to start with the people that you need to satisfy, the people that you need to make happy. and understand what their needs are. You can't start with the technology. You can't start by just picking some kind of fancy graph type and hope that it works out to communicate effectively what you need. And the purpose has all these facets. Why are you creating the visualization? Who is it for? What do they need to understand? What actions do I need to enable for them? Are they making decisions that we're trying to inform by giving them data? That's all important. How will it be consumed? The difference between a 3-inch mobile phone screen and a meter display, the amount of interactivity, the amount of detail that you can give is very different. Something that's going to be printed out in a black and white PDF report and mailed out to people in black and white with no interactivity is very different than something where you've got full color interaction. So all of these things are factors in your purpose, factors in defining what it is you're building. Finally, one nice question to ask yourself here as you're building this is, what is the most important takeaway message? What is the thing that your audience needs to know when they are complete? They've completed the reading or the understanding of this. You can pretend if this was PowerPoint and not PDF, there'd be an animation here, but we're not going to do that. The purpose should be specific. So if you say, what's the purpose? And someone says, well, I need to show our data. That's not very specific. That's not very useful. Like, of course we're here to show data. Of course that's what we're here for. But if you can say things more specifically, like, we want to show our revenue and the customer base improvements over the last 3 years to potential investors, that's a great purpose, because that tells me who my audience is, it tells me the things that they care about, it tells me what the data types that we're going to talk about are. It gives me a limit in time, so that I'm not showing 10 years worth of data, I'm only showing the 3 years because that's what matters. This is a really, really good specific purpose, so we like this a lot. Your success with the visualization or these other communications requires providing answers to the audience. Your answers that they can then take with them and make decisions based on the answers, based on the things they've learned. So saying, we're showing revenues, that's fine. You can take that same visualization and give it a different title. You can, instead of a title that says revenues, you might have a title that says, the state of Washington shows the most improved revenues by percentage of all states from 2012 to 2015. It's the same slide, it's the same content, but now I'm handing my customer or my audience, I'm giving them an answer. An answer said, this is the most important thing that happened. So if you're able to tell people what the answers are, especially if there's a certain answer you want them to learn, if you tell them the answer, they don't have to try to learn it themselves. You can just give that to them. Content. So less is more. Just briefly, someone I know took the United States Census data from 2010 and plotted a dot for every human in the census. So this isn't a map, it's just a collection of dots of humans. He did, in fact, later on do the same thing by adding the census from Canada and from Mexico. I don't have that illustration, unfortunately. This is something like 300 million dots. That's a lot. And we can learn some things. We understand that there are more people in the East than in the West. Oh, by the way, the color here, this is racial or ethnic makeup. So we can see that in the southeastern part of the United States, there's more of these green dots, and in the southwestern part of the United States, there's more of these orange dots, and there's some red dots in different places. But with 300 million dots, we can't have a lot of really interesting conversations about what we're looking at here. It's just a little too much data. If we focus a little bit, this is now, instead of 300 million dots for the entire nation, this is a small piece of Brooklyn, New York City. So now we're looking at probably tens or maybe hundreds of thousands of dots instead of hundreds of millions of dots. So we're 3 or 4 more orders of magnitude smaller than before. And now we can see some really fascinating patterns here. We can start to ask questions about, what is this one group of red dots doing in this whole neighborhood, this whole bunch of blocks that are all blue? We can talk about which of these neighborhoods has the best public transportation. We can talk about how far is it to go to the grocery store. We can talk about property values and how those are changing. So we can have real more meaningful conversations here when we focus down on a smaller set of data than if we were looking at the entire data set. So the point of this is you want to act in an editorial capacity, use your ability to focus on a much smaller piece of the whole world's worth of data, limit the data to just the answers that you want to be able to communicate. So, and the closer you can get to answers and communicating small amounts of useful focused data rather than a large amount of unfocused data, the more effective you can be. This is my favorite dashboard. This is a 1-bit dashboard. Is it raining or not? I'm late for the bus. I have to run out the door. I want to grab my jacket. Which jacket do I need? I don't care about the animated storm clouds coming in from the side and the artificial rainbow of the low pressure zone coming in from the east. It's like, I just need to know if it's going to rain today. Just give me an answer. Umbrella, yes or no. So this is taking a huge amount of data that goes into forecasting the weather and giving it to me in a very, very clear answer, rather than giving me a lot more data. So it's a little bit of a trivial example, but I like it. By the way, apologies. I think when I exported from PowerPoint, it marked up my fonts, because I promise this is not exactly how this layout was made. So we've talked about purpose first. Who's your audience? What do they need to know? We just spent a couple of slides talking about content, how to focus down the information. The next few slides, we're going to talk about structure. How do you pick the right graph? It turns out that different graphs, because of how the eye and the brain work, different graphs really facilitate different types of understanding. They communicate different types of data more or less effectively depending on the style and the shape of the graph. So as you're picking the structure, you can't just pick one that you think is cool and then decode it. But if you want it to be effective, it's more important to pick a structure that is going to support the type of communication that you need. So bars are really good for comparison. It turns out our eyes and our brains are really excellent at these very, very small differences in length. And when we say length here, really what we're talking about is the position at the top of the bars. If you look, for example, here in the middle of week 2, the pink and the orange bar there, those are very, very similar in length. But I assume that most people in the room have the ability, if you've got regular standard eyesight, you have the ability to see that there's a small difference in the length of those bars. And if you look at the scale that we're dealing with, that's like a 1% difference. That's just a few pixels, right? But our eyes and our brains are really good. We have really sophisticated software and pattern matching hardware in our eyes and our brains that let us see these tiny, tiny differences. So if we want to compare things like value, which is more, which is left, bars are a really excellent way of doing that. Now this is the same data set, and now I've mapped it with lines. And I want to point out here that with these lines, it's very easy for me to look at one, let's say that these are product sales over a week. It's very easy for me to look at the orange line and see how it goes up and down over the course of the week. Sorry, over the course of the 4 weeks. If you go back to this slide, I can sort of do that with the orange line. But this slide with these bars, this provides a very easy comparison within a given week. It's a little bit harder to track one given color week over week. This one with the lines, this gets us two things. One is the lines imply continuity, they imply change over time because the line themselves connects the dots, and that's leveraging sort of a fundamental interpretation of our brain. So that's why you see line graphs for time series data. There's some other changes that allow this to be differently useful than bar graphs, but we're going to keep it short today. Pies are great, nothing wrong with pies as long as you use them appropriately. There's a few strong considerations with pies. You really only get a few slices that are relevant. There's not a specific number. It's not that 4 slices is fine, 5 slices is bad, but the more slices you get, the less resolution and accuracy you get on the remaining. So I like to think that there's only a few relevant slices. You maybe get 4, 5, 6 relevant slices, depending on how big they are, and after a while, everything just gets too small to see. You're also not going to get precision with the pie graph. Our eyes and brains that are very, very good at detecting things like differences in length are very bad at detecting things like size differences in these wedges. We just don't have the hardware and the software built into our brains that are good at that. So very often with pies, you'll see the labels in addition to just the shape itself. And then there's one nice best practice that you can do, which is you can sort these slices so that going in a clockwise direction, you go from the largest to the second to the third and all the way down to the smallest ones. And that allows comparison of the first 2 or 3 large ones to be easy. Things to avoid, we're going to talk about reasons to not get into very quickly. In the left corner here, radar graphs. If you have data that is cyclical, if you have, you're talking about frequency of calls to the call center by time of day, that's cyclical data that goes around a 24-hour clock. That's a perfectly good use of this. But if these axes are totally independent, as they are in this graph, sales, marketing, development, customer support, the shape that this makes, the little colored glyph of line in the middle, that's as much an artifact of your choice of axes as it is of the data itself. And that has the possibility to be very misleading. So we don't recommend that unless your data's pies are not 100%. This pie down here in the corner, this is the 193% pie. It's 93% larger than anything in reality. Don't do that. In the upper right corner here, this circular graph, the problem with circular bars like this is there's 2 ways to read it. One of which is the absolute bar length, which is, we can see that this blue bar is the longest and the green bar is the second longest. And the red bar is the third longest? Well, I'm not sure. No, these bars are labeled not by length of bar, but they're labeled by fraction around the circle that they've gone. And the problem is, no matter whether you design it to be bar length, obviously the red bar that says 50 is much longer than the green bar that says 60. So you can design it one way, but half your audience is always going to get it wrong and interpret it that way. Don't do that. Finally, really, 3D anything, it necessarily distorts the data. When you have a 3D projection like this, it's extremely difficult to look at in this case, these bands on these towers here and project them back against my scale. Right, you can't actually read real numbers off the scale here. It's very difficult to do. The one exception I would say with 3D is if you have data and tools that are inherently based around 3D, like you're modeling, turbulence over an airplane in 3 dimensions. You're a sophisticated consumer. You have sophisticated tools for it. In that case, yes, 3D is not a terrible choice. That was structure. Now we're going to move on to formatting. So formatting is color, it's typography, it's interaction, it's grid lines, it's tooltips. I like to think of this as the frosting on the cake. It's important. It adds appeal, it helps focus attention, but beautiful frosting will not save a bad cake. You have to get your purpose correct, your content and your structure, all of these things need to be correct first, and if those are correct, then the frosting will be good. If you have kind of ugly frosting on a delicious cake, it's not as exciting to consume, but it'll still, taste good and hopefully you'll be full at the end of it. The job of formatting is to provide appeal and also to highlight the things that are important. So I have here, these are both drawn in Excel. All of the defaults are wrong in Excel. You can do good work in Excel, but you basically have to change all the defaults. So in the left one, I've turned on everything bad in Excel. You've got the interesting sort of sponge paint textured background and these 3D ribbons, which if you try hard at it, you can change them back and forth from being one floating above the other one to one being in front or behind the other one. I defy anybody in the audience to take any value off either of those colored ribbons and map it back to the grid lines, the 3D grid lines in the background to determine what the actual values there are. The dates aren't terrible in that one, I'll give it that. The one on the right, I've just turned off all the noise. I didn't fix the date formatting, so the dates are still ugly, but you can see it's a much cleaner graph. And that's mostly just been done by reducing the noise. Now, another thing that I could do, for example, is I could individually label every dot. I could label just the highest and lowest points. It depends on what people want to learn from this. But by using my formatting intentionally and being careful with it, I can really clarify the data that I want to call attention to. Here's a table of how to apply your formatting. Many people have drawn tables like this. This is one that I've drawn. You can see there's a URL at the bottom of the page there, complexdiagrams.com/properties, so that's my blog. If you go to this link, there's a whole description that you can download that tells you how to use this. And this essentially tells you, given a data type, what's useful and how to do the formatting. So I recommend checking that out. It's all for free, easy to do. Here we are, the summary. You have to know your purpose. If you don't know your purpose and who it is and who it's for and why you're designing it, you'll have a very difficult time being accurate and successful. You want to focus your content to what's necessary and not give too much. You want to select a structure that is useful for revealing the data and relationships that are important to communicate. And focusing should be really to help focus people. Formatting should be to help focus people and not to distract. And like I said, I'll give you the link to the slide deck, and there's a bunch of other details here, links and whatnot. There it is. How'd I do?
Perfect. Thank you. Thank you. Thank you very much. Do we have questions? We have time for one question, maybe? 2 questions? No? Anyone? Well, if you're interested in knowing more about the work of Noah, you can go to complexdiagrams.com. Is that correct?
Sure.
Yeah, exactly. Well, vous pouvez aller à son site.
You guys know what to put the last screen back? I want to take a picture.
Yes, likewise.
I want to take a picture.
All the information's there.
I took a picture of it, but
Yeah.
I want to take another picture.
But actually, it will be on the.
You're going to put
I
the link
don't
on.
believe you. I want to see it now.
Can you please put the last slide with your links?
Yeah, one second.
Wow. Yeah, use the summary.
The links.
The last page.
Yeah, that one.
And that's the summary.
No, we don't want the summary, we want the references.
No, the one with the links.
URLs, links, references.
Yeah, that's the one.
Hey, leave it up there. Leave it
I'll
there.
email it to you.
Thank you.
Thank you very much, Noah. We have to move on, but thank you very much. It was really interesting. So let's hear it for Noah Iliinsky. Thanks. Thank you. Thank you so much. Perfect. Thanks.